This video will explore in depth the trapezoid. So first of all, what is a trapezoid? In this course, we are going to define a trapezoid to be a quadrilateral that has at least one pair of parallel sides. This is important. I want to point out to you that this says at least one pair. So anybody with one pair of parallel sides would automatically, by definition, be a trapezoid. But any quadrilateral with more than one pair, namely two pairs, would also be a trapezoid. So that can be a little tricky for some people sometimes. As far as vocabulary, the sides that are parallel are called the bases. And if it has a pair of sides that's not parallel, those sides are called the legs. So in the picture here, you see the sides that are parallel, or the bases, and you see the sides that are not parallel, which are called the legs. Now, some other vocabulary that you should be familiar with is the median, which is sometimes called the mid-segment. The median, sometimes called the mid-segment, has two things that you need to know about it. First of all, you need to know that the median is always parallel to the bases. And second of all, you need to know that the length of the median is always equal to the length of half the sum of the bases. So in other words, if I look at my picture, MN is called the median. He's parallel to base DC and to base AB, and his length is half the sum of those two purple bases. Another way to say this might be to say that the length of MN is equal to the sum of the two bases, DC and AB, divided by 2. Or, in other words, the average of the two bases. So again, whatever way makes sense in your head is the way I want you to think about it, whether it's the average of the two bases or half the sum of the two bases. One more vocab word that you need to be aware of is an isosceles trapezoid. And unlike a triangle, where isosceles refers to the length of the sides, when we talk trapezoid, isosceles actually refers to the angles. Because in this course, we're going to define an isosceles trapezoid to be a trapezoid that has congruent base angles. So in this picture, segment DC and segment AB would be our two parallel bases. We know this trapezoid is isosceles because either base angles at A and B are congruent, or those base angles at D and C are also congruent. So again, what makes an isosceles trapezoid, or what makes a trapezoid isosceles, are these congruent base angles. Now, once you know that a trapezoid is isosceles, we also know that some other things or some other factors fall into place. The first of which is that its legs are congruent, and the second of which is that its diagonals are congruent. All right, so we've explored some interesting vocab. Let's go ahead and see how we might use the vocabulary along with our properties of the trapezoid in order to solve some problems. Down at the bottom of the first page, they're asking us to find the measure of each angle in that trapezoid. So segment AB and segment DC are our parallel bases. I know that because if I were to extend line segment AD and extend line segment BC, they would intersect, and therefore they can't be parallel. And you really need to remember and know very well your properties of parallel lines here. So if I'm thinking about segment AD as being a transversal, this angle that measures 78 and that angle at D are same side interior angles, or interior angles on the same side of the transversal. And because they're same side interior angles, they have to be supplements. So the angle at D has to be the supplement to that 78 degrees, or in other words, 102 degrees. And likewise, if I consider this red transversal over here, the two angles in that trapezoid again are same side interior angles, and as such have to be supplementary. So supplementary to 132 is this angle 48 degrees up here at B. And again, notice this says find the measure of each angle inside the trapezoid. I've now found the measures of all four of those angles inside the trapezoid, and I'm done. All right, so there's a problem that deals with the property of trapezoids, namely that property being those parallel bases. In number 2, they're asking us to solve a question dealing with a midsegment. And really, there's two properties you have to know about the midsegment. You have to know that it's parallel to the bases, and you have to know that it's either half the sum of the bases or it's equal to the average of the two bases. So in this particular instance, segment ST is a base, and segment RA is also a base. Segment MN is a midsegment, and as such, he's either going to be half the sum or the average of those two red bases. Now, one thing that's very, very, very important, and I am going to include in the key ideas, is that anytime you're dealing with this mid-segment problem, you want to make sure that you put the formula first down on your paper. I can't even tell you how much simpler this will make so many of the problems. So again, I'm always going to put that formula down first, and that's really, really, really important. So important, in fact, that I might get my creative pen out here and I might star that. So here's what I mean when I say formula first. The midsegment, MN, is either equal to half of the sum of the two bases, so half of the length of ST plus the length of RA, or if you like that second one, segment MN is equal to the average. So the average is going to be their sum divided by 2. So again, it doesn't matter which one you use. I would pick one and get really, really good with it, but make sure you put that formula down on your paper first. Why? Because now all I need to do is substitute in. In place of mn, I'm going to replace that in the equation with 19. The st I'm going to replace with a 4x minus 7. The segment RA I'm going to replace with a 6x plus 5. And that's all over 2. So again, once I put that equation down, then all I need to do is substitute in, and the rest is somewhat straightforward and uncomplicated. When I simplify the numerator of that fraction, I end up with 10x minus 2. And I can either divide the 10x minus 2 over 2, or I can simply go ahead and cross multiply. So 10x subtract 2 is equal to 38, making 10x is equal to 40. And lastly, solving and getting that value of x that's equal to 4. Excellent. Well, I know you've been waiting for it. So up at the top of the next page, you wanted it, you got it. How do we prove that a quadrilateral is a trapezoid? Well, in order to meet the definition or the criteria for being a trapezoid, it has to have a pair of parallel sides. So as soon as I can show that a particular quadrilateral has a pair of sides that are parallel, we know that quadrilateral is a trapezoid. If we want to prove that it's isosceles, things get a little bit trickier. But namely, we have to show that it has one of two different properties. We can either show that its base angles are congruent, or we can show that its diagonals are congruent. But again, one of those two, it either has to have congruent base angles or it has to have congruent diagonals. All right, so let's go ahead and take a look at this example. I'm going to go ahead and I'm going to begin by graphing that quadrilateral. So 1 minus 4 10 minus 4, line 2, and 2, 2. And those are respectively A, B, C, and D. Clearly, I can tell from my picture that segments AB and CD are the two bases. I'm going to use slope to show that they're parallel. So slope of segment AB from the graph is 0. The slope of segment CD from the graph is also 0. And I'm going to tell anybody reading my paper that I got these guys from the graph. If you wanted to use slope formula, by all means you could. It would be a little bit longer, but it would be just as nice in getting that job done. All right, so now I'm going to go ahead and conclude that segments with equal slope are parallel. So that makes AB parallel to CD. And now ABCD is a trapezoid because it has a pair of parallel sides. That's it. That's all there is to showing that something's a trapezoid. But now I need to show that he's isosceles. I have one of two options. I can either show that the base angles are congruent. Unfortunately, on the coordinate grid, I don't have any way of showing that. So my second option is to show that the diagonals are congruent. And I'm going to show that the diagonals are congruent by finding the length of those two green diagonals. So this involves use of the distance formula. I'm going to write it down on my page. So we're going to get some good practice using distance. I'm going to tell the reader that what I'm finding distance for, first of all, is segment AC. And I'm going to go substitute my values into that distance formula. And when I substitute in there, I end up with square root of 100, making the length of segment AC 10. And diagonal DB is the other one. And again, I'm going to go plug that what's underneath the radical sign into the calculator. And I end up with square root of 100, or in simplest form, 10. So he's a trapezoid because he has a pair of parallel sides. I'm going to say now he's isosceles because his diagonals are congruent. All right, and as always, thank you for the gift of your time. I do want you to take a few minutes and go ahead and write down the key ideas or the important takeaways that you think are important from this video, and we'll talk about those the next time I see you when you come back to class.